Imagine a world 120 light-years away, bathed in the dim red light of a distant star. A world significantly larger than our own, shrouded in a thick atmosphere and potentially harboring a vast global ocean. This isn't science fiction. This is K2-18b, an exoplanet that has just become the focal point of humanity's relentless quest for life beyond Earth, thanks to the extraordinary capabilities of the James Webb Space Telescope. The preliminary data it has delivered isn't a definitive "we found them" moment, but it is undeniably the most tantalizing whisper. We have received yet a hint of something truly profound lurking in its alien atmosphere. Get ready to have your cosmic curiosity ignited. Welcome back, intrepid stargazers, to FACSI, and today we're embarking on an in-depth exploration of the electrifying discoveries surrounding K2-18b. We'll dissect the science, unravel the implications, and try to understand just how close we might be to answering one of humanity's oldest questions. Are we alone? This isn't just about a few chemical signatures. It's about the potential for a second Genesis, a testament to the universe's boundless creativity. To truly appreciate the significance of the JWST's findings, we need to rewind a bit and understand the journey that brought K2-18b into our scientific spotlight. Discovered in 2015 by the prolific Kepler Space Telescope, which used the transit method, observing the slight dimming of a star as a planet passes in front of it, K2-18b immediately stood out. Its location within the habitable zone of its M-dwarf star, K2-18, suggested the crucial possibility of liquid water on its surface. The habitable zone, often nicknamed the Goldilocks zone, isn't about finding Earth twins, but rather regions around stars where temperatures could allow liquid water to exist, a key ingredient as we understand life. However, K2-18b threw us a curveball early on. Unlike our rocky Earth, its size a staggering 8.6 times the mass and twice the radius pointed towards a different kind of planet. Scientists categorized it as a super-Earth, a class of exoplanet more massive than Earth, but less massive than ice giants like Uranus and Neptune. But more intriguingly, its low density hinted at a substantial atmosphere, potentially one rich in hydrogen, enveloping a water-rich interior. This led to the exciting concept of a Hycean planet, a world with a vast water ocean beneath a thick hydrogen-dominated atmosphere. These Hycean worlds are now prime targets in the search for life, because they could potentially support microbial life very different from what we know on Earth. Enter the James Webb Space Telescope, humanity's most advanced eye in the sky, specifically designed to peer into the infrared universe. Its unparalleled sensitivity allows us to analyze the faint light that filters through exoplanet atmospheres as they transit their stars, a technique known as transmission spectroscopy. Think of it like shining a light through a prism. The atmosphere acts as the prism, absorbing certain wavelengths of light depending on its chemical composition, leaving behind a unique fingerprint. By meticulously analyzing these absorption patterns, scientists can identify the gases present even in atmospheres hundreds of light years away. And this is where the recent groundbreaking observations come in. The Webb telescope, using its near-infrared spectrograph NIRSPEC, meticulously analyzed the light passing through K2-18b's atmosphere, and the data revealed a compelling cocktail of gases. We're talking about a significant presence of methane CH4 and carbon dioxide CO2. While these molecules can be produced by geological processes, volcanic activity on Earth, for instance, releases both their abundance in K2-18b's atmosphere, especially in a hydrogen-rich environment, raises intriguing questions about potential biological origins. On Earth, certain types of life, particularly anaerobic microorganisms, produce significant amounts of methane. But hold on, because the story gets even more captivating. The data also hints at the potential detection of dimethyl sulfide, or DMS3. This is the molecule that has the scientific community buzzing with cautious excitement. Why? Because on Earth, the overwhelming majority of DMS in our atmosphere is produced by marine microorganisms, primarily phytoplankton, those tiny, plant-like organisms that form the base of the ocean food web. DMS plays a crucial role in Earth's sulfur cycle and even influences cloud formation. Finding it in K2-18b's atmosphere would be a strong, albeit not definitive, biosignature, a chemical imbalance that's hard to explain without the presence of life. Now, it's crucial to emphasize the scientific process. The detection of DMS is currently considered preliminary and requires rigorous follow-up observations and in-depth analysis. Scientists need to rule out any potential false positives or non-biological processes that could, in theory, produce DMS in K2-18b's unique environment. The Webb telescope is scheduled for more dedicated observations of K2-18b, which will be instrumental in either confirming this tantalizing hint or revealing alternative explanations. This is the painstaking but essential work of science, meticulous verification and the relentless pursuit of accuracy. Beyond these key molecules, the JWST data also reinforces the idea that K2-18b possesses a hydrogen-rich atmosphere and strong evidence for the presence of water vapor. This further strengthens the Hycean world hypothesis, a planet with a deep, global ocean potentially interacting with a rocky core beneath a vast hydrogen-dominated atmosphere. Such environments, while drastically different from Earth, could potentially support life as we don't know it, perhaps microbial life adapted to these unique conditions. So, let's circle back to the burning question. Did JWST definitively discover alien life on K2-18b? The honest and scientifically accurate answer is a resounding no. However, what the James Webb Space Telescope has done is deliver the most compelling evidence yet for a potentially habitable world exhibiting chemical signatures that are, on Earth, strongly linked to biological activity. This is not proof, but it is an incredibly significant step, a cosmic breadcrumb trail leading us closer to a potential answer to one of humanity's deepest longings. This landmark observation underscores the transformative power of the James Webb Space Telescope. Its ability to dissect the atmospheric compositions of exoplanet with such unprecedented detail is revolutionizing the field of exoplanetology. It's opening up entirely new frontiers in our search for habitable worlds and ultimately, for life beyond our pale blue dot. We are no longer just counting planets. We are beginning to characterize them in ways we could only dream of a few decades ago. The implications of confirming life on a Hycean world like K2-18b would be paradigm-shifting. It would redefine our understanding of the conditions necessary for life to arise and the diversity of life that might exist in the universe. It would spark a new era of scientific inquiry, pushing the boundaries of biology, chemistry, and astrophysics, and profoundly impacting our philosophical and theological perspectives on our place in the cosmos. Of course, this is just the beginning of a long and exciting journey. Numerous questions remain unanswered. What kind of life could thrive in a Hycean environment? How would its biochemistry differ from terrestrial life? Could there be non-biological pathways to produce the observed chemical signatures in K2-18b's unique conditions? These are the complex and fascinating challenges that scientists are now eagerly tackling, and the upcoming JWST observations will be crucial in shedding more light on these mysteries. The saga of K2-18b is a testament to human curiosity and our relentless drive to explore the cosmos. The initial findings from the JWST are not the final chapter, but rather the beginning of an incredibly exciting new one. As we await further data and analysis, the possibility of finding life on this distant world hangs in the air, a tantalizing prospect that fuels our imagination and underscores the profound potential of scientific discovery. We will, of course, keep you updated on every major development right here on your YouTube channel name. So, what are your thoughts on the K2-18b revelations? Does the potential detection of DMS ignite your imagination? Share your theories and speculations in the comments section below. Don't forget to give this video a thumbs up. If you found it informative and engaging, subscribe to Faxi for more deep dives into the wonders of the universe, and hit that notification bell so you don't miss our next cosmic exploration. Thank you for joining me on this incredible journey into the unknown. The universe is full of surprises, and K2-18b might just be one of the biggest yet. Keep looking up, keep questioning, and keep exploring.